Have you ever wondered what really goes on inside that roaring beast strapped under a jet's wing? Not just air goes in, fire comes out, but what actually happens in there, second by second, blade by blade, explosion by explosion. Today we're cracking open the jet engine. No fluff, just pure mind-blowing mechanics. Let's get into it. 1. Air intake. Every jet engine starts its job by sucking in air from the front. You might have seen that big, round opening at the front of the engine. It's like the mouth of the engine. As the airplane moves forward, air naturally flows into this part, but the engine also has fans at the front that help pull in even more air. These fans are huge. They're made with ultralight, super strong materials, and they spin incredibly fast. Their job is to grab as much air as possible and push it into the engine. Now, this air isn't just going straight through and out the back. Oh no, it's about to go through a full transformation. 2. The fan. So, that giant front fan you see? It's actually the first major part of the engine and plays two key roles. First, it directs some of the air straight to the back of the engine without heating it up. This bypass air actually creates most of the thrust in modern jet engines. That's right, most of the push that moves a plane forward isn't coming from fire or explosion. It's from cold air whooshing out the back. The rest of the air goes deeper inside the engine for some serious high-pressure treatment. This is where the fun begins. 3. Compressor section. After the fan, the air enters the compressor section. Think of this part like a really intense series of pinwheels. These spinning blades squeeze the air tighter and tighter, making it super high pressure. Why? Because compressed air helps fuel burn way more efficiently. The more tightly packed the air is, the more powerful the engine becomes. There are usually several stages of compression, meaning the air gets squeezed again and again as it moves forward through the engine. This section is filled with rows of rotating and stationary blades. The rotating ones spin, obviously, but the stationary ones help redirect the air in the right direction, so it hits the next set of blades just right. It's like a perfectly choreographed air ballet. By the time air finishes this section, it's under crazy pressure and has a lot of energy packed in it. 4. Combustion chamber. Now comes the really exciting part. The combustion chamber. This is the heart of the engine, where the magic of fire and speed happens. So far, the air has been pulled in, squeezed hard, and is now ready to meet fuel. The engine injects jet fuel, kerosene to be exact, into the compressed air and sparks it. That mixture of air and fuel catches fire instantly, creating a high-energy explosion inside the combustion chamber. This controlled explosion releases a massive amount of hot gases that expand really fast. But it's not just some random boom. Everything is carefully timed and balanced. The chamber is built to withstand extreme heat and pressure, and the shape of the chamber helps direct the flow of these exploding gases toward the next stage. 5. Turbine section. Now, here's the cool part. Those hot, high-pressure gases from the combustion chamber shoot straight into the turbine section. And guess what? The turbine is directly connected to the fan and compressor up front. That means the force of the exploding air actually spins the blades in the turbine, which in turn keeps the entire system running. It's like the engine powers itself using its own exhaust. The turbine blades spin at insane speeds, often more than 10,000 times per minute. They're made of super high-tech materials that can survive heat hotter than lava. And this section is critical because if the turbine didn't spin, the whole engine would stop working. This is what makes the engine self-sustaining. As long as there's air, fuel, and a spark, it can keep going. 6. Exhaust. After the turbine, the air has done most of its job. It's already burned and expanded and lost some pressure, but it's still moving really fast. Now, it heads straight out the back of the engine through the exhaust. And this final step is where we get thrust, that powerful push that propels the aircraft forward. Newton's third law is at work here. For every action, there's an equal and opposite reaction. When that fast, hot air shoots out the back, it pushes the plane forward with an equal force. That's what makes jets fly. So while it may look like the engine is just blowing air backward, it's actually pushing the whole airplane forward using physics. Bypass air. Earlier we mentioned bypass air, that cold air that never went through combustion. In modern jet engines, especially the ones on big passenger planes, this bypass air does most of the work. These are called turbofan engines, and in them, about 80% of the thrust comes from the cold air pushed by the big fan. Only about 20% of the power comes from the hot gases. Why? Because bypass air is quieter, more fuel efficient, and better for long-distance flying. It keeps the engine cool and creates a smoother, more powerful flow out the back. That's why today's jet engines are getting bigger and bigger at the front. The bigger the fan, the more air it can push without needing to burn more fuel. Now let's pause for a second and ask the obvious. How does this whole system stay together? You've got insane heat, spinning parts, explosions, and high-speed air all happening at once. Jet engines are built using some of the strongest materials on Earth, like titanium and ceramic composites. Everything inside is precisely engineered down to the tiniest detail. Temperatures in some parts of the engine go above 1,000 degrees Celsius. And yet, everything has to be light enough for the plane to carry. The spinning parts, like the fan, compressors, and turbines, are attached to shafts that run down the center of the engine. These shafts are balanced perfectly. If anything gets even slightly out of sync, the engine can vibrate, get damaged, or even fail. So, maintenance and inspection are a huge part of jet engine safety. Moving in, if you are wondering, how is the engine controlled? Well, modern jet engines aren't just left to run wild. Pilots control them from the cockpit using a throttle lever. But what's really doing the hard work is the FADEC, Full Authority Digital Engine Control. FADEC is basically a computer brain that controls everything inside the engine. How much fuel to inject, how fast to spin the fan, how to respond to changes in air pressure or speed. It constantly monitors sensors inside the engine and adjusts in real time. It's like an invisible hand that keeps everything balanced and running smoothly. Thanks to FADEC, pilots don't need to worry about every single detail. They just set the power they want, and the system figures out the best way to deliver it safely and efficiently. Jet engines versus rocket engines. Now, you might be thinking, hey, don't rocket engines also shoot fire out the back? Aren't they kind of similar? Well, yes and no. Rocket engines carry their own oxygen, which means they can work in space where there's no air. Jet engines, on the other hand, need to suck in air from the atmosphere, so jet engines can't work in space. Also, jet engines are way more efficient than rocket engines when flying in the atmosphere. They use air, they recycle their own energy, and they're designed to run for hours. Rocket engines are more about short, powerful bursts. The different types of jet engines. While we've been talking mostly about turbofan engines, the ones used in commercial airliners, there are actually several types of jet engines. There's the turbojet, which was the original jet engine design. It's much simpler and was used in early jet fighters. These have no bypass air, it's all about speed and thrust. Then there's the turboprop, which mixes a jet engine with a propeller. It's used in smaller aircraft and is super efficient at low speeds. There's also the ramjet and scramjet, engines that don't even have moving parts. They rely on the plane moving so fast that the air is naturally compressed. These are mostly experimental or used in missiles, but for now, turbofan engines are the kings of the skies. They're reliable, efficient, and surprisingly quiet for the power they produce. Why jet engines are so safe? You might think that something so full of heat and moving parts is risky, but actually, jet engines are among the safest machines ever made. Every single part is tested and checked again and again before the engine is even installed on a plane. Engines are built to keep running even if something goes wrong. If a bird flies into the engine, it can keep going. If a blade breaks off, there's a special casing that keeps it from damaging the rest of the plane. And on top of that, most planes have more than one engine. Even if one engine fails completely, which is extremely rare, the plane can still land safely using the other one. Conclusion. And that's everything going on inside a jet engine, from the moment air enters at the front to the final powerful push at the back. It's a high-speed, high-heat, high-pressure chain reaction that's so precisely tuned, it keeps millions of passengers flying safely every day. Jet engines are truly one of the greatest inventions ever, blending physics, chemistry, and engineering into a machine that turns air and fuel into flight. If this breakdown made jet engines a little less mysterious, let us know in the comments what part blew your mind the most. And for more amazing content, don't forget to hit the subscribe button.